Hey everyone, and welcome. Ever wonder how forensic experts can solve a crime when there's no weapon in sight? Well, today we're diving right into that. We're going to explore the incredible science of how wounds tell a story and how investigators can literally read an injury to figure out the exact weapon that caused it. So, picture this. You've got a crime scene, but the weapon is gone. Nowhere to be found. You'd think that's a dead end, right? Not even close. For a forensic pathologist, the single most important piece of evidence is already there: the body itself. It's not just a victim, it's basically chapter one of the story, and it's holding all the secrets. All right, so where does this all begin? Well, it starts with the most obvious clues, the ones you can see right on the surface. This first look, the initial external exam, is where a weapon begins to give itself away. Okay, so the very first big split is between sharp force and blunt force injuries. Think of sharp force wounds as clean, almost surgical, like what you'd get from a knife or a piece of glass. But blunt force trauma, that's the complete opposite. It's messy, it crushes, it tears, it leaves these ragged edges, and something called bridging tissue, which is where the skin stretches and rips but doesn't slice cleanly. Just from that one observation, investigators are already starting to build a profile of the weapon. And then you have firearms. They leave a really distinct signature. It's like a tale of two holes. The entrance wound can be surprisingly neat, almost small, but it's got these telltale signs like an abrasion ring where the bullet literally scrapes the skin. And if the shot was up close, you'll find soot or stippling. But the exit wound, that's a whole other story. It's almost always bigger, way more irregular because the bullet's been tumbling and losing steam. Just by comparing the two, investigators can figure out the bullet's path. So you could almost create a quick reference guide, right? A standard knife, clean, straight incision. But a serrated blade? That's going to leave ragged edges with these tiny little notches. A hammer might leave a very specific depressed fracture, especially on the skull. And with a shotgun, the pattern of the pellets tells a story all its own. The wider the spread, the farther the shot. Seriously, every weapon writes its own unique signature on the body. But everything we've talked about so far, that's just the surface. The real story, the full picture, is hidden inside. And for that, we have to go to the autopsy, where the weapon's true path and power are finally revealed. Once inside, the pathologist basically becomes a detective, meticulously tracing the wound track, and every step provides a critical clue. The direction, that tells you the angle of attack. The depth, that can hint at the length of the blade. Following the path of destruction through the organs reveals exactly what happened internally. But maybe the most crucial part of this whole process is the chance to find something amazing: tiny, hidden fragments of the weapon itself. And this is so important because, no weapon is perfect. As it travels through the body, it can actually leave behind microscopic breadcrumbs. We're talking tiny metal fragments, splinters of wood, even flecks of paint that can break off and get stuck in the tissue. And this isn't just random gunk. This is a direct physical link back to the weapon. Okay, so finding these little fragments is a huge step. But figuring out what they are, that's where the real high-tech magic comes in. So now we're heading into the forensic lab, where the investigation goes from what the eye can see to what only a microscope can. When it comes to firearms, the comparison microscope is the undisputed champion. What it does is let an examiner look at two things side by side: the bullet from the crime scene and a bullet test-fired from a suspect's gun. See, every gun barrel has these tiny, unique imperfections that leave scratches, called striations, on a bullet. It's literally a ballistic fingerprint. And if those microscopic fingerprints are a match, boom. You just tied that bullet to that one specific gun. But wait, it gets even cooler. What about those little fragments that aren't bullets, like a tiny metal chip? For that, scientists turn to something called SEMEDX. Yeah, it's a mouthful, but what it does is amazing. The machine basically zaps a tiny fragment with electrons and reads the X-rays that come off of it. This tells them its exact chemical makeup, element by element. So that little metal flake isn't just metal anymore. The lab can now tell you it's a specific steel alloy, one used by a particular brand of knife. Incredible, right? And the lab's toolkit is just packed with amazing tech. They analyze gunshot residue to figure out how far away the shooter was. They use X-rays and CT scans to find hidden fragments still inside the body. They can even match tool marks left on bone directly to a weapon. Heck, they even use histology, that's looking at tissue on a cellular level, to see if a wound shows any signs of healing, which can tell you if it happened before or after death. It's a whole arsenal of science, all pointing toward one goal: getting to the truth. So let's recap. We've got clues from the surface, we've got evidence from inside the body, and we've got hard data from the lab. What's next? Well, now comes the really crucial part, putting all those puzzle pieces together to build the final picture. And this is how they do it. It's a path to identification. You start big, right? The shape and size of the wound give you a general class of weapon. Then you zoom in, looking for distinct patterns, like serrations or specific fracture types to narrow the field. Next, you match any fragments you found to a specific material. And the final step, the clincher, is getting that microscopic confirmation, like the ballistics match, that can point to one single weapon. It's just beautiful deductive reasoning at work. But, and this is a really important but, we need a little dose of reality here. As incredible as this science is, it does have its limits. The story the body tells isn't always crystal clear. Lots of different knives can create very similar-looking wounds, and sometimes clothing can get in the way and obscure the details. Forensic science gives investigators powerful clues, for sure, but it isn't always a magic wand. Which really brings us to the final critical point. While the body can tell us the type of weapon that was probably used, the definitive, airtight conclusion, the kind you can take to court, that almost always requires one more thing: finding the actual weapon. You have to be able to physically match it to the evidence taken from the victim, whether that's a bullet, a tiny splinter, or a DNA sample. When you step back and look at it, the science is just incredible. By learning to read the language of wounds, investigators can piece together the what and the how of a crime with stunning accuracy. The story written on the body is this silent testimony that can lead them straight to the weapon. But the biggest question of all, the why, well, that's one story the body can never tell.